Welcome back. This is section 9.1.2. This is the basics of hypothesis testing. As promised, we're going to go in detail about every step. So what I want y'all to do is go back in the previous session and take a look at the chart that I have given y'all. The first step in your hypothesis testing is to write your null hypothesis and your alternative hypothesis. So in these, there will be your claim. Okay, so let's go ahead and look in detail what this means. So null hypothesis, oops, that's good. Okay. Null hypothesis, the easiest way, null, there's no change. Everything is equal. Null is nothing, no changes, equal. So the key term to your null hypothesis in identifying your null hypothesis is equal to. If you see a equal to, it's your null hypothesis. Null and alternative are opposites of one another. They're complements of one another. So if it's equal to, that means it could be not equal to, greater than, or less than. So if you see not equal to, greater than, less than, it's alternative. Okay? You must say, Miss, what does that even mean? Let's take a look. I'm going to the first problem here. A brokerage firm is curious about the proportion of clients who have high-risk stocks in their stock portfolio. Let the proportion of clients who have risk stocks be P. If the brokerage firm wants to know if the proportion of clients who have high-risk stocks is less than 15%, what are the null and alternative hypotheses? Okay, so I would highly recommend you all to pause the video here, reread the problem and see what's happening. Okay, so I would like you to go ahead and do that. I can pause because I have to continue. So here, a brokerage firm is curious about the proportion of clients who have high risk stock in their stock portfolio. So let the proportion of clients be P. They said let it be P, okay? If the brokerage firm wants to know if the proportion of clients who have high risk is less than 15%. So they want to find out if it's less than 15%. One thing you have to understand in hypothesis testing is you make claims about the entire population, not about the sample. You don't have to claim anything about the sample because you have your math right there. It's the population that you are not sure of and you're trying to find out about. So here they say less than, right? So I'm going to go ahead and look at, I'm going to use a red marker. So whichever is not my option, I'm going to go ahead and cancel it. But I know I have to start with my null hypothesis and I know I have to have my alternative hypothesis. So if the brokerage firm wants to know proportion of clients who high stocks is less than 15%. So what are they claiming? So let me erase this really quick. Da, 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 da. So they want to know the proportion of stock less than 15%. Okay? You always start with your claim. That's what they want to know. This is less than. When it is less than, what do you think this is? Null hypothesis or alternative? Let's scroll up and up again. Yeah. And there you have it. If it is less than or greater than, it's my alternative. So I know this is my alternative. What is the opposite? If I have one less than, my null is going to be equal to. Remember, your null hypothesis is always equal to. That's blindly. Blindly, null hypothesis is equal to. So now once I have these two, let me go ahead and see which one is my option. So my alternative is less than. Let me look for which my alternative is less than. I know my alternative is, look here, option 4. In option 4, they're using mean, but they did not talk about mean. They talk about P. So this is not my option. You see, I'm going to simply cancel that. I think I canceled it in a very bad way. I'm going to go ahead and use a highlighter. I'm simply going to cancel this one. And the next one is my alternative is less than. Look at my alternative here. It's equal to, so that cannot be my option. My alternative is less than. Here my alternative is greater than, so that cannot be my option. So the only option that I'm left with is, so both of them have to match. If I look here, my H naught matches and my HA matches. All right, let's do a couple more. Again, blindly H0 is equal to everything else is HA. A website developer wished to analyze the clicks per day on the newly updated website. Let the mean number of clicks per day be mu. If the website developer wants to know the number of clicks per day is different than 200 clicks. Pause. Let me use my Dandy tool. Different. What does different mean? Different could be more than, different could be less than. So different is not equal to. Fair enough? On the average, what is the null and alternative? Instead of looking at the options, I like to write down my own and then work my way backward. So here they used mu. Did you all know? Even I put up a statistical analysis on the videos that I put in, and I see which students actually watched it and which students did not. On the average, I do all my stats with y'all as well. I say, how many of them clicked this? How long did they watch? I take a look at everything. Don't worry, I'm not going to check anyone, but I usually like to see how many students are viewing it and how many students click it, how long do they spend, just for my reference. Okay, so I will always start with the claim. So here, what are they doing? They say if the website developer wants to know if the number of clicks per day is different. So they want to know if the average clicks are not equal to 200. When they say different, different means not equal to, right? When it's not equal to, by default, it is HA. You know that by now, right? What is my H naught? Doesn't matter what my H naught HA is, my H naught is always, there you go. Again, this will always remain the same. So look what's happening. This 200 will be the same for both of them. The mu will be same for both of them. The only thing that is different, will be, or opposite, will be the signs. So that's the key. Your H naught and HA will have everything the same except the signs. So this is what I have. Now I'll see which one matches. So I'm looking for HA not equal to. So definitely not this one. Definitely not this one. Definitely not this one. Which one only has an option of not equal to? Option D. There you go. All right. One more. A medical journal publishes, can you see? Yeah, a medical journal publishes, let me expand this one. Yeah. That's perfect. A medical journal published new medical research about diastolic blood pressure. Let the mean diastolic blood pressure reading be mu. So here again, look for what they're using, mu, mmHg. I'm guessing that's the degree or that's the units that they measure. If a doctor wants to know if the new medical research discussed in the journal results in diastolic blood pressure readings that are on the average less than 75 mmHg. Doctor wants to know, again, use the same units. Look what I'm doing here. He wants to know mu is less than 75. As soon as I write that, I know that is my HA. Remember, H naught is blindly equal to. H naught, everything stays the same except the sign. So mu stays mu, 75 stays 75, H naught blindly equal to. So this stays for H naught and HA, mu stays mu, 75 stays 75. Only thing that's different is your symbol. Now go ahead and see which option has these. If I look, I'm looking for HA less than. So not this one, not this one, not this one. Which one is it? Boom. So my option is, oh, what a perfect circle. My option is option A. Fair enough? All right. Da, 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 da. Now the next one is very important. We will carry this into the next steps of hypothesis testing. So please be very careful, all right? So we are identifying and when explaining the difference between one-tailed and two-tailed. So what is one-tailed and two-tailed? They're not the tails, but we'll see. Okay. Look at H naught. Everything is equal to, right? We've seen that. Everything is equal to. So H naught is not what I'm looking at when I'm trying to figure out what tailed test it is. I'm going to erase this so you know this is not what you will be looking at. So if I ask you what tailed the test is, you will only look at HA. Why is that? Because H naught is equal to. It's not going to tell me anything. Look at HA. I'm going to start with the right-tailed. Look at my HA, greater than. Greater than is which side? To the right-hand side. So it is a right-tailed test. Less than is which side? Left side. So it's a left-tailed test. Not equal to could be greater than or could be less than. So it's a two-tailed test. Fair enough? And again, the only thing that determines your tail is your HA. Don't look at H naught. You only look at HA. Write this down. HA determines which tail. Greater than, right-hand side. Less than, left-hand side. Not equal to, two-tail. Greater or less. Now let's go ahead and do the problems. Da 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 da. Where is it? No, I wanna. Yeah. Can you see this? Okay. Okay. I should have got my water bottle. A loan officer claims that the average interest rate that compounds annually on a 5-year loan is greater than 5.75. When I'm saying greater than, you automatically know which tail that is. If a loan officer wants to conduct a hypothesis test, should he use left, right, or two? Well, you know exactly what it is, right? But I always like to write with my alternative and my null hypothesis. Again, my alternative is, what does he want to know? Average interest rate. So mu is greater than 5.75. Remember what my null is? Blindly everything stays the same. Mu stays mu. 5.75 stays 5.75. Only thing that changes is equal to. So again, my HA is greater than. Greater than is which side again? Right hand side. So it's a right-tailed test. I should have used a different color, yeah? All right, it's as simple as that. Now let's try the next one even without working it out. An office manager who works at finance company claims that the employees spend less than. The key term is less than 5 hours. Which tail? Greater than is right. Am I going right for y'all? Probably left, yeah. The camera is flipped, so you get the idea, right? So greater than is right. My right, I write with this one, so right. Less than is left. This is my left, right? All right. So it's less than. I'm going to use a different color here. Less than is by default left tail. See that? All right, let's look at the next one. A social worker who reads the journalist article about families on welfare in a particular town thinks the proportion is higher. Higher is greater than. The social worker would like to carry out a hypothesis test and test the claim that the proportion on families of welfare town is greater than. Why is the hypothesis right-tailed? Okay, remember what is only my alternative determines my hypothesis? This is right-tailed because direction is not specified. I love such options where just randomly throw them at you. This is a right tail because direction is not specified. No, this is a right tail because direction is specified. The population parameter is greater than the specified value. This is a right tail because direction is specified. The population parameter is less than. No, not this one. More information is needed. So it clearly says it is greater than. When they say it's greater than, which direction am I going? To the right hand side. So my option is option B. Fair enough? All right. Is this the last one? Yes. Again, if you have any questions or comments, please reach me through email or text me through Teams. I will post these PDFs right below the video. And again, take care and good luck.